Okay, since it's 5 past starting time, I guess it's time to kick off. Welcome to another session at the Microsoft 365 Virtual Marathon. It's 5 past 11 here, local time in the Netherlands, and I'm here to talk with you about Windows Autopilot and share some experiences that we had deploying devices with Windows Autopilot. Sure, hope you're having a good conference so far. Seems like there's a lot of great content being shared. Thanks for the guys at the SharePoint conference, Microsoft 365 conference, for organizing such an amazing and huge event with 36 hours of live content, up to, I believe, 16 tracks at the same time. Make sure to mark your calendars for March next year. And make sure to have a look at our sponsors sponsoring this event. Of course, it can pay off to pay them a visit. Why? A little raffle at the end of the event. Go to the vendor's booth, check some sessions, watch the videos, and submit your answers, and you might win one of those 3 Oculus Quest all-in-one devices. Pretty sweet, pretty cool stuff. I must say I do enjoy attending a virtual conference like this. There's only one thing I'm missing out on a bit, besides from the actual contact and networking you do and meeting other people. You can do that in VR, that's pretty cool. But I miss the stickers. I have some stickers right here, 365 Dude stickers and a little called tech support sticker. You can get those. Go to stickertrade.me and you can find an online platform to exchange all your stickers with everyone from around the world. So make sure to do that. Now, a quick note about me. My name is Ralph. I work at the Proact in the Netherlands as a cloud architect, and I specialize in the modern workplace. Which means I do mainly Azure AD, Intune, enterprise mobility and security. And that's what I'm here to talk about, Autopilot. Look me up on Twitter @Robje or online, 365dude.nl. I won't have much time to look at the Q&A today. Well, it's a bit hard switching between presenting and answering questions. So at the end of my slide deck, you'll see some contact information for me. So if you have any questions, well, you can post them in Q&A. I look into having to check them, please feel free to reach out on LinkedIn or Twitter or something like that if you have any questions regarding the topics I talk about today. So what we're going to talk about, moving away from legacy management, using Intune to manage your devices, cloud first, mobile first. To be able to do that, you need to enroll your device in Intune. There are a few ways to do that. You can do it manually through the settings options in Windows 10. If you have any domain joined devices, you can use a GPO to target those devices and enroll them in Intune like that. Or you can do it automatically when Azure AD joining your device. So when your device joins the Azure Active Directory, it automatically will be enrolled in Intune, and you can do your management from there. And that's what Windows Autopilot is built upon, because Windows Autopilot will help you helping the end user to join their device to Active Directory and get them enrolled into Intune. That's exactly what Windows Autopilot does. It joins your device to Azure AD. It's something the end user can do, right? When he takes the device out of the box, he starts it up and he will be greeted with the Autopilot screen. So they can actually enroll their device into Azure AD. Because it's a user action, you get to hide some specific questions from the end user, some stuff you don't want them to care about, some things you already decided on as a company, and you can make sure the end user is not a local administrator. And that's a big difference with the normal strategy of handing the end user the device and saying, well, here's the out-of-the-box experience, click some settings, and when you're asked to specify if it's a personal computer or a work computer, just say it's a work computer. When you do that, device is AD joined, is enrolled into Intune, but the user doing that will always be a local admin. And by using Autopilot, you can prevent that. So what does the Autopilot end user experience look like? What does the end user see when he takes a device out of the box and powers it up? Well, it's pretty straightforward. It's just a normal out-of-box experience for Windows 10. So the device will start booting up. You can select your region and your keyboard layout, which of course is important because you will be asked to enter your credentials a little bit later on. So you want to make sure that you have the right setting for the keyboard layout, especially if you have any strange characters in your password, for example. So the device will connect to the network. In this example, my device is joined to a physical network using a network cable, but you can also do this through Wi-Fi. You can even connect to Wi-Fi using a captive portal. The wizard will just talk you through and do all the configuration for you. Once connected to the network, the device might update Windows 10 if that's necessary. It will check if there are any new versions, and if it's not, you will be prompted to enter your credentials. Well, this device is used in my organization, the 365 organization, so I will be asked to enter my username and my password to log on to my organization. And of course, I have MFA enabled, so I will be prompted to do the multi-factor authentication. And once I approve that, it will move on. Quick side note, if you haven't enabled multi-factor authentication in your organization yet, please do it. It will prevent about 98 or 99% of breaches currently seen in Microsoft 365. So that's a no-brainer and a quick win. Well, it's connecting with the Microsoft 365 endpoints in the cloud to get the configuration needed for my device, and it will set it up for me. And I will be shown this screen. So the device will do some configuration in a few different steps. It will prepare the device, which means it will join it to Active Directory, Azure Active Directory in my case, enroll it into Intune and do some stuff like that. And the next step, it will do some device setup. And that will provide you with some policies, especially for devices, some software that's meant to be shown on certain devices instead of certain users. Stuff like that. Everything that's targeted to a device will be done in the device setup. It's important to remember that because we will come back to that a little bit later on in my presentation when we'll talk about whiteglove. So my device is going through the device setup stuff, doing everything that needs to be done. And you might see that after the device setup, it will reboot. Sometimes it does, sometimes it doesn't. That depends on the software being installed during the device setup task. If software being installed here requires a reboot of the device, it will reboot. And I think in this case, for this demonstration, it will actually reboot after it sets up the device and before it switches to setting up the account settings of the device. I see a question coming by in the Q&A in the meantime from Sylvia. Where in Microsoft 365 do I set up Autopilot? Stay tuned. I'll show you in a few minutes in one of my next demos on using Windows Autopilot. Oh, and that's Siri thinking I'm talking to him. So let's see. I actually have pre-recorded this demo, so I'll skip forward a bit. So the device setup is complete, and in this case, in fact, the device will reboot before continuing with the user setup. Just a moment. So after the reboot, the device will show the normal configuration, getting everything ready for you, all the screens you're used to when setting up a new Windows 10 PC. And then it will proceed with the account setup. Well, you can click the Show Details button and you'll see what the device is actually doing. It's joining your organization's network. It will apply some security policies. Install some certificates if that's necessary in the current configuration, fix some network connections, and install some apps when needed for this device. And once that's done, I'll just scroll ahead a bit. It's actually finished, and it will bring you to the Windows Hello setup page where you can set up your PIN in my case, because this is a virtual machine, so no biometrics here, no face recognition and no fingerprint. I get to set up a PIN code. I'll type in a 4-digit PIN code, which is 2 digits too short, so I'll need to use a 6-digit one, change that. So you can see that it actually checks the settings in your Azure Active Directory setup to make sure that your device is compliant with those settings. So I've set up my PIN code for this device, and I'm all set. So I can go ahead and I'll be brought to the desktop, and I can use my device. In this case, because it's such a short demo, no actual software is deployed to the device, but in real world you can deploy software during this autopilot process, and the device will be ready to use with all the software installed once it reaches the desktop. So what do you need to do to enable Windows Autopilot in your environment? What settings do you need to configure? Well, first of all, you need to enable automatic enrollment. Like I said before, Windows Autopilot does just join the device to Azure Active Directory. And if you wish the device to be managed by Intune, you need to configure Intune to automatically manage all devices enrolled in Azure AD. This does require an Azure AD premium license. Well, that doesn't seem to be a problem nowadays, because if you use Intune, you most probably use the Microsoft 365 bundle instead of the Office 365 bundle. Sorry, which includes Azure AD Premium. And if you don't use Microsoft 365 but you use Intune, you probably use the Enterprise Mobility and Security Suite, which also includes Azure AD Premium. Next step is to create and assign an Autopilot deployment profile, which sets all the settings for the Autopilot configuration. You can configure the enhanced status page. That's optional, but I would always advise to do so. That's the actual page you just saw in the first demo of the end user experience, showing all the steps that are being done to the device and blocking the user from actually accessing the desktop until every step is processed and all the required software is installed. So that's pretty important. And of course, you need the device to be known in the Autopilot backend. Once the device boots up, it enters the out-of-box experience and the network connection is set. The device makes an internet connection and queries the Autopilot service hosted by Microsoft to see if the actual ID of the device, the serial number and the hardware hash, is known somewhere in the database, and to what tenant this device should be joined. So the device should be known in the Autopilot backend before you can actually use the Autopilot deployment. So what does it look like? Again, this is a recorded demo because I didn't want to be dependent on my actual internet connection today. So I go to devices. First of all, it's important to know I use the endpoint.microsoft.com URL. I don't use the actual Azure portal. Somewhere in the next 2 or 3 months, I believe by the start of August, Intune in the Azure portal will be deprecated, will be removed. You must use the endpoint.microsoft.com portal to do this configuration. So in this portal, I go to devices, enrollment, and then Windows enrollment, and choose the automatic enrollment option to set the automatic enrollment. For me, it's set to automatically enroll all users in MDM when they Azure AD join, but you can specify a group. I leave it to all, and you can do the same for mobile application management, but that's not necessary for Autopilot. I have to check if my domain is correctly configured. I can test my domain here. To do automatic enrollment and to manage your device through the Intune servers, you need to add some CNAME records to your domain name to make sure the device knows, based on the email address you enter when you set up the device, to which MDM authority it should connect. Well, for me, the CNAME is set configured already, so I can proceed and set up the next bit. That's Windows Hello for Business. I'd like to enable Windows Hello for Business. I would require a TPM chip, set the pin length to 6, do some additional configuration on biometrics, use anti-spoofing, or allow or disallow security keys for sign-in. And once that's set, I can go on to the next step, which would actually be the configuration for the enhanced status page, which shows all the different options on the actual setup screen. So we do have a lot of options here. Show app and profile configuration progress. That's a progress screen we just saw in the end user experience. So what is actually being done to the device while we're waiting. And of course, we can set a timeout period. So if something goes wrong or a software install hangs during the ESP show phase, by the end of these 60 minutes, I will be prompted that an error occurred and that my device couldn't be provisioned correctly. Of course, I can specify the error message and allow the end user to collect some log files. And one of the most important things, I can block the device until all apps and profiles are installed. So once the ESP is loaded and the setup is actually running, the end user won't be able to actually use the device just until the entire setup is complete. That goes for profiles and Wi-Fi settings, for example, but it also goes, and you see that in the last option, block device use until these required apps are installed. So if you have some applications that you want to be installed on the device before bringing the end user to the desktop, you can specify those here. Sorry, let me just scroll back for a second. This is why I never record demos, but always do them live. There you have it, block device until these required apps are installed. So in this case, I can select some apps that are required for specific users and check or uncheck if I want the enhanced status page to wait until this application has been successfully installed before bringing the user to the desktop. It's important to know that this way you can make sure that some software is actually on the device before using it. So the next step, the deployment profile. This is the actual profile that will set all the autopilot settings for the end users. In this case, it's my default profile. This is an important option. I can convert targeted devices to autopilot. So when I have a group in Azure Active Directory with devices that are not yet known in the autopilot service, but are actually Azure Active Directory domain joined, I can automatically target all those devices and convert them to autopilot. So there's no need to harvest the information from the device regarding the hardware ID and the hash and stuff like that. The Autopilot or Azure AD service does that automatically for you. It's pretty cool stuff. I usually set it to yes, and I check the out-of-box experience. So what is shown and done for the end user. In this case, I want the deployment mode to be user-driven. So there's actually some user interaction when setting up the device. You can create a self-deploying profile, which is excellent for example, kiosk devices, where there's no user interaction required at all when setting up the device. So you create a profile, you create all the policies, you make sure the device is known in Autopilot, and you just ship it to your shop somewhere far away where you want to use it as a kiosk device. And all they have to do is connect the device to the network and the screen and boot it up for the first time, and everything will be configured automatically. In my case, I configure my device as Azure AD joined, but you can hybrid Azure AD joined devices from Windows Autopilot. So it will be joined to both your Azure AD, Azure on-premise Active Directory. That's pretty cool too. I can choose to hide the license terms and the privacy settings. Important to know, if you hide the license terms and the privacy settings from here, you will automatically accept them. So it's something you have to think about as an organization if you want to acknowledge those settings or not. If you think as an organization, I do acknowledge those license terms and those settings, I'll just hide them so the end users won't be bothered with all the questions about tracking information, speech recognition and stuff like that. The next step is to configure what sort of account you would like to be used for the user enrolling the device. Like I said before, you can choose here to have a standard user which will have no administrative rights on the device, or you can choose to have the end user be an administrator. It's something you have to think about as an organization when deploying your modern workplace, is how much free space you will give the end user to manage their own device. Of course, when you make an end user an administrator on the device, local admin, make sure you have the right security in place to check everything that's being done on the device and to detect breaches and stuff like that. Next option is the option to allow the white glove out-of-box experience. We'll talk about that a bit later. But know that you can enable or disable it in an Autopilot profile. You can set the language for the device, the regional settings like date, time, and the comma separators and stuff like that. This option has been in Intune and in the Autopilot deployment profile for a long time, but it didn't actually work until the 2004 Windows 10 update, which was released, well, 2 or 3 weeks ago. So now it will actually work. If you set a language from here, those regional settings will be automatically applied to the devices. Automatically configure the keyboard. Be careful with that. If you have devices shipping to different countries where they use different keyboard layouts, because you might have problem, like I said before, with authenticating if you have any strange characters in your password. And you can apply a device name template. So when the device is enrolled through Autopilot, it's Azure AD joined, and it will then be renamed using this template. And this template does have some variables, but not much. You can use letters and numbers, of course, and hyphens. And you can use two different variables. That will be the serial number. You specify with the serial tag, a little macro to add the hardware-specific serial number. So you can have a unique device name for each device just based on the serial number. Or you can use a random string of numbers. And you can specify how long that string should be. So in my case, I'll have all my devices called 365 dude with a hyphen, and then a random string of 4 digits to specify which device it is. That random string is always calculated on the device side when renaming the device. So you might end up with devices having the same name because they calculate the same random string of digits, especially if those strings aren't too long. So if you have a string of 2, there's only 20 possible options, 30, and that's it. So I prefer nowadays to use the serial macro because it makes it easier to look up the device in your CMDB, for example, based on the host name. You already know the serial number if you have the host name for the device. So I set all those different options and saved them. And now my Autopilot profile is set, and I can actually start deploying devices through Autopilot. But before I do so, I need to make sure my devices are known in the Autopilot backend. So I have one device already known here. You can see it's a serial number used to register the device, and it's actually a virtual machine I use for some demo. So I have one device already in my organization to be used with Autopilot. Now, how do I get some extra devices imported into my organization? First, let's talk a little bit about what Microsoft thinks about shipping devices to your end user. It's pretty straightforward. Your device vendor, be it HP or Dell or Lenovo or whatever, sells you a device and ships it to you. And it presents you with a CSV file of information of the device. So that's some basic information like serial numbers, but also a hardware hash used to uniquely identify the device that's calculated on the device. And you can use that information to import these devices into Autopilot. So when you boot up the device will calculate its own hardware hash, checks with the Autopilot backend, and see if the device is known in the backend. So it will know what device it is and what settings to use and which tenant to connect to. If you are a Microsoft partner, you can use the PKID specified by the vendor to import those devices for your customer through the Microsoft Partner Portal. That's pretty sweet too. So the device is then sent directly to the end user in this example. And because we have the Autopilot profile configured and the device already known in the Autopilot backend because we imported the hardware information, the end user just boots up the device once it gets it out of the box, has the self-service experience setting up the device, and the device is ready to go. It's managed, it's secured because it's enrolled into Azure AD, it's enrolled into Intune, and the end user can just use the device without some technical guys actually touching the device or doing some setup before it reaches the end user. So the device is being used, and in the end, the device is either dismissed, it's end of life, and it will just be removed from the organization, or there's something wrong with the device, or the device gets shipped to another user, for example. And we can use the Autopilot reset function within Intune to reset the device. It will be then remotely wiped, set to the out-of-box experience, and it can be shipped to another user, which then goes to the same self-service experience setting up the device. So how do we get this Autopilot information into the Autopilot backend? There are a few options. You can harvest the data from the device. There are some PowerShell scripts which just get the data like the serial number and the hardware ID, the hardware hash from the device and export it to a CSV file. So you can use the CSV file to import that information into Autopilot. You can convert existing devices into Autopilot, like I've shown before in the Autopilot information, in the Autopilot profile. You can hit the checkbox that says, well, convert an existing device. So if you have devices that are already Azure AD joined, but you don't have the actual hardware information, you can use that to convert them to Autopilot. They're already in the organization, so Azure AD/Intune reads the Autopilot information from the device for you and automatically enrolls them into the Autopilot backend. The information can be provided by the reseller, like I said before in the example used here. You get a CSV file with Autopilot information or PKIDs for each order you place and the devices that are shipped, or you can preload the device with a JSON. What actually happens when a device connects to the Autopilot backend when first booting up in the out-of-box experience, and there is an internet connection, the device checks with the Autopilot backend if it's a member of a certain tenant based on the hardware ID or the serial number, and the Autopilot backend will send back a JSON file with all the information for the Autopilot profile being used. You can mimic that. You can get the JSON information from the Autopilot service to a Powershell, and you can then use the JSON file you get to preload on your device. So if you have a batch of devices and you want to image them through SCCM or through the Microsoft Deployment Toolkit, you can make a task sequence that actually puts the JSON on the device in a specific folder. And then the device already has the Autopilot information, so you don't need to enroll those devices into Autopilot because they already have the JSON. And the first time they connect and they boot up, they read the JSON file, connect to the Autopilot backend, and they will be automatically converted to an Autopilot device if you have checked that option in the Autopilot profile. So this way, without actually enrolling the device into Autopilot by hand, you just place the JSON on it, and the first time it connects to the Autopilot service or to Azure Active Directory, it will be automatically enrolled into Autopilot for the next time the device is reset. So what does it look like in the real world? In my case, I have a device and I will enroll it into Autopilot through the internet. So my device is in the Netherlands. I need to set my keyboard layout because I will run some scripts and I need to type in some code. So I will set to make sure my keyboard layout is okay. And you can see in a few seconds that this device is not already enrolled into Autopilot. Why? It's connecting to the network and it's showing me the license agreement for which I said, well, I don't want it to be shown. What I did here is I pressed the Shift F10 key combination, which will bring up a command prompt for me to do some stuff. And I want to drop down to a PowerShell. So I'll do that because I want to run some PowerShell scripts to actually connect the device to the Autopilot backend. Well, I need to run some scripts, so I have to make sure my execution policy is correctly set. For this, I'll just use the bypass mode and I have to confirm. And to install the script, I need to connect to a package provider. In my case, it's a NuGet package provider. So I'll have to install that package provider first. Of course, again, I'll have to confirm that I'm actually sure I want to do that. Well, okay, move on. And then I can install the script. And the script in this case is called, you have guessed it, Upload Windows Autopilot Information, Device Information. So I install the script. And I install it for all users. And I don't want to be nagged by any further confirmation checkboxes. So it will install the script on my device. You will see it download in a few seconds. And then I can use the script to actually read the information from the device and automatically upload it to my Microsoft 365 tenant. So the device is automatically registered with the Autopilot backend. So the script is installed. Let me just clear my screen for a second. I'll specify my tenant. In my case, it's a 365.microsoft.com organization. And I can provide an order ID. If you purchase devices from your vendor, you can use this order ID in the CSV file you import to group specific devices based on their usage or based on the time they were purchased to do some cool stuff in Azure AD with some automatic or dynamic groups. So I get an authorization token from Intune right now. because using the script will require me to connect to the Microsoft Graph API to actually send the information of the device to the Autopilot backend. So I authenticate with Intune, have to do multi-factor authentication, of course. And you can see I get a bearer token, which will be used in my next request to actually authenticate to the Graph API. So I'll switch to my PowerShell scripts folder to check if the script I have just downloaded from the NuGet package provider is actually installed. Let me just check all the PS1 files. Yep, there it is. Upload Windows Autopilot device info. .source it, and I can run it. I'll have to specify the tenant I want my device to be enrolled in. Well, of course, I have that in a variable. There we go. And I want to specify the order ID, which is called the group tag in Autopilot Backend. So these are the settings read from the device. You can see that the serial number is read, the product key if it's there. This is the ID for the actual import job in the Autopilot backend, and it gives us back a state, so we can make sure the device is actually imported. Let me just double check here. You can see that I actually imported the device with the serial number ending in 37, and the device is registered in the Autopilot setup with the group tag we specified. The profile, the Autopilot profile is assigned, so if I boot up the device, get to the out-of-box experience, it will use the Autopilot profile specified here to enroll the device into Azure AD. So that's pretty cool. The device is in Autopilot right now, and what's important to know is that when you enroll the device into Intune or Autopilot, I must say, it's already available on Azure AD. You haven't yet Azure AD joined the actual device because that's done during the Autopilot progress, but it is already in AD. It's hidden and it's there based on the serial number, but it's actually there. So you can already add the device to some specific groups if you would like to. For example, for specifying which Autopilot profile to use if you separate those based on groups. There are some dynamic groups you can use, for example, to define all your Autopilot devices, or to use the group tag we just specified when uploading the device to separate devices into specific groups. So you can, for example, specify a group tag that states that this device should be a shared device or a kiosk device, and you can create a dynamic group based on that group tag and use that to apply specific Intune policies, for example. The purchase order ID, if you purchase the devices from a vendor and you get the information delivered by them, you can also use the purchase order ID because it's available as an object on the actual device in Azure Active Directory. So what does that look like? Here you see the device we just uploaded, serial number ending in 37, profile status is there. So let's look at the actual devices. It's a Windows device, of course, but we can look under all devices and we can see it's not really there. This is a different device that's already enrolled into Azure Active Directory, but it's not the device we just enrolled into Windows Autopilot. Why? The device is not yet Azure AD joined. It's there, but it's hidden. So if you go, for example, to the Windows 10 devices group, which is just a static group, which has no members so far, we can add the device here because the device is already in Azure AD based on the serial number. It doesn't have an actual device name because that won't be set until the device is Azure AD joined using the naming convention specified in the Autopilot profile. But we can add the device to this group to do some cool stuff with group memberships, Autopilot profiles based on group memberships and stuff like that. So it's good to know the device is in Azure AD. It's based on the serial number. You can add it to groups. Once you actually enroll the device into Azure AD using Autopilot, the object in Azure Active Directory that's already there will be renamed to the new device name. And this will also carry on across device reinstallments. If you have a device with a specific naming convention and you reset the device through Autopilot and you have it enroll again, Azure AD will see it's the same device, because it's actually the same serial number and the same hardware hash, and it will just rename the object in Azure Active Directory and not create a new one. So I talked about some dynamic groups. Let's create one. In this case, for all my Autopilot devices, it's a dynamic device group, of course, and I have to add a query to specify which devices I want to be included here. So I use the device physicals IDs object for the device in Azure AD, and it must contain the value CTDID. All Autopilot devices have this value. So if you just specify this query, you will make a dynamic group which includes all Autopilot devices, which you can use, of course, for example, for targeting policies in Intune. When we were importing this device, we specified the group tag. So we can build a dynamic query based on that, of course. It's still the device physical IDs object in Azure AD. But this time it must contain a specific value and not a setDID value, but the order ID. Like I said before, the group tag object in Intune is matched to the order ID object in Azure Active Directory. So in this case, I want the order ID to be Autopilot demo, like we specified when enrolling the device into the Autopilot backend. The query is automatically built, and if we save it, we can check then if the device is actually in the group. Well, it's not. There are no devices in this group. That's because the membership update takes a while to progress, and after a few minutes you will see the device is automatically added to the group based on the order ID was specified when importing the device. So it's here. It's a device ending, the serial number ending in 37. And what you can see is that, of course, the device OS type and the OS version is not yet known, because all we did was take the hardware hash and the device ID serial number, send it to Autopilot to make sure that the Autopilot environment knows which device will be enrolling through Autopilot. Once the device is actually performing an Azure AD join, it will be linked in Azure Active Directory, and you will be able to see the OS type and the OS version. But right now, we only know about the hardware and not the software installed on the device, so we can't display that information. So the all Autopilot devices group we created earlier, which had the setDID value, we can see there that we have actually 2 devices in this group. The device we just enrolled with the serial number ending in 37, and the device that was already there with a different serial number, but not enrolled yet. So this way you can use dynamic groups in Azure Active Directory to target devices that are known in Autopilot, but not known in Azure AD yet. I see some questions coming in through the Q&A. I'll save them for the end of my presentation. So stay tuned and I'll make sure to answer them. Well, of course, when you take the device out of the box and you hand it out to the end user, you might want to deploy some software to the device. What's important to remember is that Autopilot doesn't do management. Autopilot just takes care of enrolling the device in Azure Active Directory. Intune does the actual management of the device. You can use Intune to deploy software and scripts to the device. Like I showed before, you can use the enhanced status space to control which software should be installed before the end user is sent to the desktop. So you can make sure that, for example, the Office suite is installed in the device before the end user can use it. And you can use some of the scripts you built through Intune to remove, for example, pre-installed software from the device. If you get a device from a specific vendor, which also includes some bloatware or like driver packages, assistant software, you can build some scripts to remove that software from the device. So if you do that, you can actually take the device, have it sent from the vendor to the end user directly, and there won't be a need to deploy the device with a clean image, for example. If you're in the enhanced status space, you can troubleshoot deployment profiles, software installation errors from the command line. That's pretty simple as well. I have a device set up here, which I have installed, or I have targeted a bogus app. It won't be able to install that app, and it states so. Well, I exceeded the time limit. So I used the same Shift F10 combination to drop down to a command line and do some diagnostics. There is an MDM diagnostics tool available in Windows 10 by default. In this case, I want to get some diagnostics information on the autopilot process and on TPM information, because whiteglove, for example, can lean on TPM for quite a bit. In this case, I'm doing this command on a virtual machine which doesn't have a TPM chip, so it will error on that, but it will just collect some information and export it, in this case, to the C autopilot.cap file, which I can then, of course, copy to a USB drive or stuff like that to actually examine the information. Of course, it's a Windows device. I can just use the event viewer to scroll around and find some errors which occurred during installation. There's the regular system event log, application event log, but also some specific event logs on, for example, Azure Active Directory, which I can use to check out what went wrong during the installation. If the error is in actually Azure AD joining the device, if it's in enrolling the device with Intune, or if it's somewhere in software installation, for example. So you can just use the regular event logs you know and log from Windows 10, even when you're in the process of deploying through Autopilot. And the last thing, I will need to drop down to a Powershell shell to do that. That's the same thing we did before, so we need to set the execution policy and stuff like that. Because we're going to download another script that will do some troubleshooting for us. It will just go through the logs, check for some known errors, and see if it can provide some comprehensive information on why Autopilot deployment failed. So this script you can install again through a NuGet, get Autopilot ESP status. In this case, I didn't specify the NuGet package provided beforehand, so it'll automatically enroll it for me. Get the script, install the script. It's from an untrusted repository. Are you sure you want to install it? Yes, of course, I'm sure. So to actually get the script and get some dependent scripts which it needs to run. And I can just start the get Autopilot ESP status script from here. Use the online switch to get some information through the Graph API, for example. Of course, I'll then need to re-authenticate because it will connect me to the Graph API. If you don't have a network connection, you can omit the online switch and you won't need to authenticate then. It will just use the local log files to do the troubleshooting, perform multi-factor authentication in my case. And it will just get the logs from the device, connect to the tenant, getting the list of application and the policies. And it will show me that in this case, the deployment failed on my bogus application, which I was expecting, enforcement failed. So by using this script, and those scripts are all available online, you can get them through the NuGet package provider, and I'll share my slides and the demos afterwards. So you can recheck the actual name of the script. By doing this, you can get a real comprehensive information on what went wrong during the Autopilot deployment. They did already build something into the endpoint management portal to have some graphic information on your ongoing Autopilot deployments. It's in preview, but you can see in my example, I have a success and a failure in our Autopilot deployment already in progress. I can click through, get some actual information, what the enrollment method is, if it will enroll into Azure AD or if it's a hybrid join, what's the operating system version, what Autopilot profile is being used. So they still keep making it easier for you to track on that information when deploying through Autopilot. Some pretty cool information right here from the Monitor tab in the Endpoint Management portal. So the next step when enrolling, whiteglove, it takes a device installation, separates it from the user configuration. So actions that don't actually require user authentication, and the first two steps in the enhanced status page we saw before, can be done without actually needing the user. So if you have software and policies targeted to the device, you can already install them without the user authenticating. And that really reduces the waiting time for the end user when enrolling your device. So to do this, the device should be trusted. So TPM2 with health attestation is required. That's the main pain point I see when using whiteglove. But when you want to use it, in the first screen of the out-of-box experience, you hit the Windows key 5 times. And you get the option to do a whiteglove deployment. Like I said, it breaks up the sequence of installing the device. Like we displayed earlier, you get the device, send it to the end user, and the end user might have to wait quite a long time before the device is ready to use, because it has to download and install all the software, which is dependent on the network speed and of course the patience of the end user. We break it up in an extra step, so the device won't be sent to the end user directly, but will be sent to your IT department, which can do some of the heavy lifting for the application installation by just running through the white glove experience. And then the device will be sent to the end user, where the waiting time for installation will be down to a few minutes because most of the software is already installed. So like I said, we have one of these devices and we have to assign it to a user, because for the white glove installation to work, the Autopilot backend needs to know what user the device is for. So it can actually target the right software and the right policies to the device. So I've set it up. I've set this device to be set up for my account. I'll take the device out of the box as an IT technician, and in the first out-of-box experience screen, I'll hit the Windows key 5 times. I get this screen and I choose the Windows Autopilot provisioning, and I'll be prompted with this screen. And I blurred out some information right here because it's screenshots from an actual customer deployment I did. But it will show the organization you will be enrolling to, the deployment profile used for this device, and the user that the device is assigned to. So you can check this as a technician. There is a companion app you can install on your Android phone to scan the QR code and do some changes here if you need to. But if everything looks good, you hit the provision button, and the device will do some pre-provisioning. And once it's done, you'll be greeted by a nice green screen stating that the Autopilot configuration is done. Or if not all goes well, you will see a nice red screen showing that there were some errors and you need to do some extra stuff to make sure the device works. So it's pretty straightforward. And once it's done, it's completely enrolled. You can hit the reseal button in the top right and the bottom right, and the device will be shut down and will be ready to send to the end user, which will then only have to do the last part of the enrollment, the specific user configuration. So the user will have to authenticate and the device will be enrolled and ready to use. So we've been doing Autopilot and white glove in the wild for quite a while, and we've run into some lessons that are pretty important to remember. First of all, bandwidth is key. All the installation you do on the device, because of the Intune profiles and the software you targeted to the device, will first be downloaded through the internet to the device. So if you are doing a quite large enrollment, you have users come together to pick up the device. It's the last bullet in my slide. Use wait time during enrollment to train your end users. So you'll have 10 users at a table going to some training while setting up the device through Autopilot. All those 10 devices will be downloading software from the internet. So make sure you have the right bandwidth to support that. Of course, test your software installation, test your policies on an already installed device before bringing them to production. I like to create an install sequence for some software, be it an MSI or a Win32 app in Intune. Have it targeted to a test device so I can install it to the company portal. And if installation to the company portal goes well, you can be sure that it always also goes well when using Autopilot. It's always best to have your device delivered without bloatware, just a clean Windows 10 install with at least Windows 10 1909 for the best experience. They did some fixes in the Autopilot process in 1909 upwards, which really enhances the end user experience. And make sure your vendor supplies you with the necessary information for enrollment. So the CSV files with the hardware hash or the PKID, you need that to enroll your device into Autopilot and to do the actual deployment through Autopilot. If you don't have that information, you will need to get that information from the device yourself. And you can do that through a CCM or through a deployment toolkit or through some PowerShell scripting. But then you will need to actually have the device, do some stuff on it before sending it to the end user, which is of course not an ideal situation if you look at what Autopilot is meant to do. Always keep it simple, hold back on policies, and give users some freedom. You can make them local administrator, of course you can, but only when using a good security suite. So Microsoft 365 E5 or E3 with the identity and security add-on, at least use that suite and include the attack surface reduction policies. App locker and stuff like that will surely make sure that your device is secured down so you can trust your users with those local admin rights on the device. If you would like to do some things that are not available through Intune or through policies in Intune, like deploying fonts or do some stuff with printers, or map a local network drive, for example, you can always use a Win32 app or MSIs for some of those things. Just package an application, create a script, make a Win32 app from it, and deploy that to the device to install fonts on a machine, for example. If you do that, I prefer to use Win32 apps over MSIs, sometimes even package an MSI into a Win32 app, because the Win32 app functionality already has the branch cache functionality when deploying software to the device. So the bandwidth I talked about before when deploying software becomes less of an issue if a device can get those Win32 packages from another device in the same network and won't have to go out to the internet to catch the actual package. So sometimes it can be beneficial to package even your MSIs, which are natively supported through Intune, into a Win32 app, just to make sure you can get the benefit of the branch cache functionality. If you want to go testing, I would highly recommend the Powershell module by Ben Reader. You can find him on Twitter, powers_hell, to rapidly build autopilot VMs with Hyper-V and Powershell. What it does, it's building a repository of some images, specifying your tenant information, and you can provision a VM on your local machine in Hyper-V through PowerShell. It will automatically inject it with the JSON payload, which contains the autopilot information. So by the time the VM boots up, you're automatically enrolled into Autopilot, and you can start testing your profiles, and you can enroll 4, 5, 6 VMs at the same time easily. So I'm almost out of time. Thanks for joining. Like I said before, if you have any questions, please feel free to reach out on Twitter or my website or on LinkedIn, or drop me an email. I'll check in on the Q&A after I finished up with the session to answer the questions asked there. Have a great rest of the virtual marathon, and there are still some hours to go. Make sure to leave some feedback on me as a speaker on the event entirely. There are some bit.ly links right below the QR code, so I can guess you already know them by heart. And this is the last slide from my presentation. Consider donating to the following charity relief funds. It's great that we're here in a virtual environment, but I would like to see you all in person the next time I present or something like that. So help out those guys. So thanks for joining, and I'll hand it back to the moderator, and the next speaker